Okay, let's look at homework 7, problem number 9. So we want to use the vectors to prove that the sum of the squares of the diagonals of a parallelogram is equal to twice the sum of the squares of two adjacent sides of the parallelogram. Right? So let's draw a parallelogram. Right, so it's gonna look kind of like this, just general parallelogram. So it's gonna look like that, and this is parallel to the base, and it's gonna be like that. Right, so this is a parallelogram. Then so we are looking at let's say we need two adjacent sides, so I'm gonna just call this guy, right, vector A right here. Right, and call this guy vector B. Right. Then we also need the diagonals of the parallelogram, so we need this guy right here. Right. Alright, this guy can be expressed in terms of vector A and vector B. Simply, you can just add the vector A and the vector B together to get there. So I'm going to just call this guy, so I'm going to just, this guy right here. We can write it as vector A plus vector B. Alright. Then the other diagonal would be going kind of like this. Right, so that's the other diagonal. And we can express it as, let's see, we can go on the negative direction on vector B, and then positive direction on vector A. So we can express this guy as vector A minus vector B. Alright, so those are the diagonals. Right, so what we need to show is this. So we need to show, right, that prove that the sum of the squares of the diagonals. Right, so we just have so first diagonal is vector A plus vector B, and we just need to square that. Right, you can put the magnitude here, it'd still be the same thing. If you take the dot product with itself, it's going to give you the magnitude squared. So plus, right, the other diagonal is vector A minus vector B. Then we need to square that, right? And this is equal to, it says that twice the sum of the squares of the two adjacent sides. So you have 2 times, right, and vector A squared, right? You can write it that way. Actually, maybe I should be a little bit more consistent and maybe write it as A squared, right? Like before. So A squared, which is going to be the same thing anyway. So because dot product with itself is going to give you the magnitude squared. Right? Then the other one is vector B is the other adjacent sides. So it's going to be vector B squared. Right? And all you really have to do is start with the left hand side. So you have a left. So proof is going to be, right, just very computational. You just start from left hand side, right? Kind of multiply it out and to see if you can get the left hand side. So I'll let you do that. So start with the left hand side, and here you have to fill it in. Then try to get to the right hand side. Right? That's it. I hope that this will get you guys going. All right.